maybe start there. Be consistent. I see that the bullet has momentum, but the block isn't moving before the collision. And then the bullet has momentum and the block have momentum after the collision. You guys good for that? You've got grams and kilograms here, so pick one and stick with it. I'm going to go kilograms, I think. But you could have gone grams. That's just fine. Just make sure that your units are appropriate. You just would write things in grams, meters per second, and not kilograms, meters per second. So I have the mass of the bullet, which is 0.1 kilograms, times its velocity, 500 meters per second, plus 0, has to be equal to the mass of the block is 1 kilogram times its unknown speed, plus the mass of the bullet again, times its known speed of 100 meters per second. So this works out to be 40 kilograms meters per second equals 1 kilogram times V. So V is 40 meters per second. Not terrible? All right. What is the impulse experienced by the bullet to do the collision with the block? This is where I would have expected a little bit of a hiccup, and a few of you experienced that. There are two sides here to impulse. But impulse is either one of these. And in your homework, you're probably doing stuff where you're having to set this equal to this and solve. That's fine. You should know to do that. But if you're asked to merely find the impulse, then pick a side. Whatever side has the information that you've been given in the problem. We were given nothing about force and time, but we know everything about the momentum. So I'm going to use this to find the impulse on the bullet, which is just going to be the final momentum minus the initial momentum. The bullet's final momentum is 0.1 times 100, and its initial momentum is 0.1 times 500, and that's going to give me negative 40 kilograms meters per second. Any problem with that? Now, if you left it in grams, that'd be negative 40,000 grams meters per second. Yeah.
Did you say if we need this side positive, would we just say 40 kilograms to the left?
Yep. Because that's the next thing I'm going to say is you should interpret what the negative sign says and indicate that this is to the left.
But we wouldn't have to write that.
If you wrote the word left, you would not have to write negative there. Yeah.
For A, we also have to write 40 meters per second, right?
You should, yes. And I didn't bring that up, but that's a good call. All right. Instead, the block gets stuck inside the bullet gets stuck inside the block, and you're supposed to figure out probably what will be the velocity of the bullet block system. Nothing on the left is any different, right? Everything on the left is the same. So that's still going to be 40 kilograms meters per second. I'm still making that positive. But on the right, the bullet and block are now joined together. So they will have a combined mass and a single velocity. Still not tough, I don't think. I've made a mistake. I'm just waiting to see if anybody's picked up on it. And I didn't intend to make this mistake, I just did. Yes, Reese? Yeah, I wrote the wrong number there. It should be 50. Sorry. Oops. I wasn't even doing that one on purpose. I just blew it.
But it wouldn't be kilograms meters per second, just meters per second.
No, it's still kilograms meters per second right now.
Oh, yeah.
Right, because this is in kilograms right here. And so I'm going to divide both sides by 1.1, and that'll give me 50 kilograms meters per second divided by 1.1 kilograms. I don't normally write out the units all the time, but we've had these are kind of weird units, and we're going to see something on the next page that's a little weird. So I'm trying to play with the units a little bit. The kilograms cancels though, and this gives us 45 meters per second. All good? All right, did you guys write a paragraph? So, I find the paragraph parts of the AP exam to be our weakest portion. And so, this semester we're going to spend a lot of time talking about what it is you need to write. And I'm going to be direct with you. I don't always know the answer on what they're looking for. We're going to look at the judges' table reads so that you guys can see the kind of conversations that take place when they're reading people's work. And you'll probably come to the same conclusion that I do, that it's not always clear what you're supposed to write. So here's how I view it. They're going to suggest vocabulary that you need to speak to. You don't need to speak to all of it, but they're going to suggest vocabulary that you need to speak to. I believe they want you to use the vocabulary correctly in your paragraph, but they want to be able to determine through context that you know what the vocabulary means. Does that make sense? So you can't simply assume that the person reading your report, your essay, your paragraph, that they will believe you when you say you know what the vocabulary means. For example, saying in this particular paragraph that the impulse is greater in the second case than the first case, which is true. The impulse on the bullet is greater in the second case than the first case. I don't think is enough, because although it is true, it's a true statement. Do you explain why the impulse is greater on the bullet in the second case than the first case? I think you need to. I think you need to say that the impulse on the bullet is greater because it had a greater change in momentum. Do you follow why that's a better statement and why it does something more? But of course, that leads to the next vocabulary word, momentum. How do you know that it had a greater change in momentum? I think you need to state that the momentum there's a greater change in momentum because the velocity had a greater change. The bullet goes from 500 to 100 in the first collision and 500 to 45 in the second collision. Which one's a greater change? Well, the second one. I think you need to connect all the dots to get the points. So I think that's the first half of this one, is explaining what happened to the bullet and why. I think the second thing you have to say here to get the credit is to indicate that the impulse on the bullet has to be equal to the impulse on the block. The question is about the block. And I think you can throw in a solid therefore at the end. That if the impulse was greater in the second case on the bullet, and the bullet and block had the same change in momentum, then the impulse on the block is greater in the second case. Therefore, sum it up. Always have your last sentence, sum it up. You okay with that? All right, this kind of stuff, like a multiple choice question, but all the choices would have Newton seconds for their units. Does everybody understand? So I don't want you to be confused by it. I'll use this picture. Okay, I'm using the picture that's right there at the bottom. I'm just going to write that this is, let's go with P initial for the bullet plus P initial for the block. I know that's a lot of subscript, but you'll understand why I'm doing that in a minute, I hope. That has to equal P final for the bullet plus P final for the block. Is that okay? Do you guys see that? I am going to, I got to pick a side. So I'm going to subtract this from both sides, which will mean that I'll have a negative P initial for the block here, because I'm subtracting it from both sides. That good? That goes away. So I get P initial for the bullet equals P final for the bullet plus P final block minus P initial block. Gonna keep going. I'm gonna subtract this from both sides now. So I'll get P initial bullet minus P final bullet equals P final block minus P initial block. All right, final step. I want to swap those so it's final minus initial. Factor out the negative, P final bullet minus P initial bullet equals P final block minus P initial block. A lot of math here, but I wanted to prove something to you because Reese wanted it proved. She said, I don't understand. And I said, you're worth taking the time. You see that this is change in momentum for the block, right? So this has to be delta P for the block. And you see that this is change in momentum for the bullet, right? Final minus initial. So that's delta P for the bullet. So in any collision, the change for one has to be equal and opposite to the change for the other. Any collision. So that's how I know. You understand unlikely to have that kind of hint on the test. Right? Bless you. So that was thrown in. That was actually on last year's test, or year before last, but I don't think you should expect to have that kind of hint on the test. How do I know that looking at this graph, the area has meaning? Bless you again. You're supposed to check two things whenever you're presented with a graph. You're supposed to check the slope and the area to see if it matches any of your formulas. I have force times time. That matches a formula, right? The area of this graph would be force times time. The product of the axes is the area, and the quotient of the axes is the slope. Force divided by time, we don't have any measurement. There's no equation that matches force over t on your equation sheet. But there is a force times t on your equation sheet. That means the area has meaning. In this case, the area is the impulse. So question A asks you what the impulse is. You just have to find the area. Now, I want you to pay attention to this because there's something here that's important, and I don't know if it's going to come up or not. This is 1/2 base times height. I don't think that's the issue for you guys. Why does it make that so thick now? Okay, base times height. So 1/2, 0.01 seconds. Why so thick? Times 500 newtons. Is that what you guys did? So 2.5 Newton seconds. Newton seconds is another way of saying kilograms meters per second. It could be used as a unit for impulse. I've never seen them use it as a unit for impulse on the AP1 exam. That doesn't mean they can't. But clearly, it's a Newton is kilograms meters per second squared times seconds. The seconds would cancel here, and this would be kilograms meters per second. This is why I was playing with the units before, to make sure we're very clear that these are the same unit. So they could give you a problem where you did all in front of you so that if it comes up on the AP exam, we're there. I'm not going to try and do those kinds of tricks on your next test. I don't need to do that. I want the test to be, based on what we talked about. This is also 2.5, Newton seconds. This is just seeing if you know that change in momentum and impulse are the same thing. Now, this being set equal to change in momentum is how you do question number 3. The cart's final momentum minus its initial momentum equals 2.5. They say the cart was at rest initially. And I believe the cart has a mass of 500 grams, is that right? So 2.5 equals 0.5 times V. Be careful with units here. In the last question, you could have done the whole thing with grams and it was fine. In this one, the value was given in newtons, so you have to use kilograms. Now, I don't know if you can make this leap, but if one cart experienced 2.5 newton seconds of impulse, the other cart had to experience negative 2.5 kilograms meters per second of impulse. I think this one's tougher. Again, I don't think this is out of bounds, do you? But I see a lot of writing, so maybe this was out of bounds a little bit. Is there any question about why I'm making this one negative? There is a question? I want to remind you, in all collisions, the total change in momentum is 0. In all collisions, the total change in momentum is 0. That's what makes it conserved. That's why one side equals the other side. That means if one gains momentum, the other loses momentum. Here, how about I prove something to you guys real quick, all right? That I can do that here. Well, anyways, we're supposed to find the final velocity. We were told it's a 1 kilogram block traveling at 2 meters per second at first. So that's going to be 1 kilogram times, I don't know the final velocity, minus 1 kilogram times 2. Oh, you're right. I'm going ahead and doing question 5, I guess. Sorry. Sorry. Don't hurt me. There. There, see? See? I was just getting so eager and so excited. So, sorry. All I had to do was put negative 2.5 for number 4. Oops. So we won't talk about Mr. Shelton's excitement about physics. That's no one needs to know. To prove something real fast. Let's go back.